All right, today we are going to look at transforming and combining random variables. Remember, random variables is what we were looking at all in section 6.1. So today we're just going to do some things with them. Oh, sorry, this first part, this isn't in your notes, but it's review from chapter 2. We're going to be doing the same thing today with random variables that we did in chapter 2 when we did our linear transformations on just a set of data. So just as a recall, when we were adding or subtracting a constant, we add or subtract that to our location. Our shape and spread doesn't change. Multiplying or dividing by a constant, our location multiplies by that. Our spread multiplies by the absolute value, and our shape doesn't change. These same rules are going to apply when we are working with random variables. So we'll write them all out in your notes. So here's where your notes are going to start. So we're going to start with multiplying or dividing by a constant and how it changes our random variable. So we're going to say we're multiplying by b. So if we multiply our random variable by b, that means we're going to multiply our measure of center, our mean, median, quartiles. In our case, mainly we're going to be dealing with the mean by whatever that value is. We also are going to multiply our spread. In our case, it's mainly going to be standard deviation by the absolute value of that, because remember, standard deviation cannot be negative. So our standard deviation will be an absolute value. And last, our shape is not going to change. So as a little reminder here from chapter 2, our standard deviation we multiply by b. So remember, if you want to find your variance is your standard deviation squared. So if you want to find variance, you have to multiply your variance by b squared, not just b, or you wouldn't end with the right answer. So an example, we have a community college considers a student to be full-time if they're taking between 12 and 18 units or /hours. We're going to let the random variable x be a student that is taking how many hours a student is taking in the fall semester. We have the following probability distribution. So this looks like a discrete distribution that we were doing in section 6.1. But instead of asking you to find the mean and standard deviation, I'm giving it to you. I'm giving you the mean and the standard deviation and a histogram of what the data looks like. Then it tells us that tuition is $50 per unit. So that means that our tuition, our total cost right here, is going to be 50 times x, because it's $50 times however many units I'm taking. So what we're doing is taking our random variable x and we're multiplying it by 50. With that in mind, there's some things we want to do. We want to answer some questions. So what shape does the probability distribution of t have? Well, you can see our shape over here in our histogram. So if I look at that, remember shape, is it left skewed, right skewed, symmetric? So this one is closest to symmetric. If I were to cut this down the middle, it's close to being the same on both sides. So the shape is roughly symmetric. Kind of see that has 3 peaks in there. To find the mean, remember that our t right here is 50 times our x. So to find the mean, go from the rules, you multiply the mean times whatever this constant is. So our mean is simply 50 times the mean of x, which is 14.65. So our mean is $732.50. To calculate our standard deviation also changes by just multiplying by the 50. So our standard deviation, notice my notation, just so that you're getting used to what the notation looks like, is 50 times 2.056, so $102.80 would be our standard deviation. If it doesn't ask you to interpret it, you don't have to, but if it asks you to interpret it, you need to make sure that you do. So that is multiplying. Now let's look if we are adding or subtracting a constant to our random variable. So now we're going to say that we're going to add or subtract. We're going to let it be the letter A for whatever it is that we're doing. It can be negative, that's okay. So if that's the case, it's going to add the measure of A to our center of location, mainly our mean, so it's going to add that value to the mean or subtract it if we're subtracting. But when we are adding something, it does not change our spread. So that means our standard deviation would stay the same. It would not change. It also does not change the shape of our distribution. So when you're adding a constant, it only changes your center. Okay? So example, if we have a large stats class, we have the score, a random variable x, is going to be a randomly selected student on a test worth 50 points. And it's going to be modeled. It's telling us it's normal. It's giving us a mean of 35, standard deviation of 5. Due to the fact that there was a difficult question, the professor is going to decide to add 5 points to everybody's test score. So y is going to be our scaled test score of the randomly selected student. We want to describe our shape, center, and variability. So y is going to be our test score, which is x, and we're adding 5 to it. So it's like x plus 5. So what happens to our shape? Our shape was normal. When we're adding something, our shape doesn't change. So our shape is still going to be approximately normal. Our center is our mean. For the rules I just gave you, you're going to take your mean of x and add 5. You add 5 to your location. So our new center would be 40. And our variability, our standard deviation, per the rules I gave you, the standard deviation doesn't change when I add, so my standard deviation stays the same. There's nothing different in it. So now we've looked at multiplying, we've looked at adding, so now we're going to put those together in what we call a linear transformation. What happens to our mean and standard deviation? So here's our linear transformation now. We're going to add and multiply by b at the same time instead of doing separate. So if that happens, then the probability distribution is going to have the same shape, so our shape isn't going to change. It didn't change with either one, so it's not going to change now. Our mean changes. All you have to do is substitute in wherever your x is in your equation, substitute in the mean for that, and a plus b times your mean, because your mean changes when you're adding and multiplying. And your standard deviation, remember, only changes when you're multiplying. So in this case, notice our formula only deals with the multiplication part. When you're adding, we don't take that into effect when we're doing our linear transformation because it doesn't change. Addition doesn't change your standard deviation. So let's look at an example of putting all this together. X is going to be the number of gallons to fill a propane tank. We're going to say that the mean is 318. Standard deviation is 42. The company is considering the pricing model of a service charge of $50 plus $1.80 per gallon. So our new random variable is going to be y, and it's going to be the amount billed. So the first thing that you should do is write what is your linear transformation. So in our case, we have the y. It's the amount billed. Well, we know we're going to pay $50 no matter what. And then we're due $1.80 per gallon, so $1.80 x. So that's what my linear transformation looks like. Here I wrote 50 plus. The 50 can go wherever. I just kind of keep it more like a linear equation we're used to with the x first. So now to find the mean, think about that formula I just gave you. To find the mean, in place of this x right here, we are just going to put the mean of x, which is 318. So I plug in a 318. Remember, mean and expected value are the same thing. So 1.8 times 318 plus 50 would give us $622.40. Then we want to find our standard deviation. So remember, your standard deviation, when we're looking at our formula here, only takes into consideration the multiplication part. So we only care about this 1.8 times x. We don't care about the addition. So we're just going to plug in our standard deviation. 1.8 times our standard deviation of 42 gives me $75.60. It asks you just what are they. It didn't ask us to interpret them, so these are our final answers. Notice notation. You're going to have to start writing things in correct notation. I will be starting to ask for that, so make sure you're paying attention to that and getting used to it. Next, here, we're going to combine random variables. So we're going to have more than one random variable. So we're going to have random variables x and y. So we're going to say that we're going to add them together and get the sum. So I'm going to let s be the sum of x plus y. What's the mean? So when I add two random variables together to get the mean, I'm going to add the two means together. Okay? If, on the other hand, I want the difference, so now I have my two random variables x and y, I'm going to subtract them. So d is x minus y. So if I'm subtracting them to get the mean of my new random variable, I subtract my means. Make sure that you are subtracting in the correct order. If it's x minus y, it's mean of x minus mean of y. If they flip the order, you have to flip the order when you are subtracting them. So let's take a look at an example here. We're going to say Pete charges $150 per passenger, Aaron charges $175 for a Jeep tour. So we're going to let C be the amount of money that Pete collects per day. E is going to be the amount of money that Aaron collects, and it's going to be on some day. What we want to know, I'm giving you the mean, the mean of C is $562.50. The mean of E is 542.50. It says from earlier work. We didn't do earlier work. I'm just giving it to you. We want to find the sum of their two amounts that they get per day. So my S is C plus E. We want to calculate and interpret this time the mean. So if my S is C plus E, that means to find my new mean, I just add them together. So add my two means together, which would give us $1,105. So that's easy enough to find. Now interpreting it, I'm going to start getting really picky on interpreting. I've given you sentences. I'm going to do a sentence here. It's a little bit different than before. As long as you understand one of them, it's fine. So here I say Pete and Aaron expect to collect a total of $1,105 per day on average over many randomly selected days. When we did this in section 6.1, I kind of did this differently. I said over many randomly selected days on average Pete and Aaron would expect. So I just kind of flip-flopped how I wrote it. It doesn't matter, but if you don't have over many, and if you don't have on average, and then in terms of the problem, you're not going to get full credit for writing your sentence. So make sure you're taking the time and writing your sentence. Okay, so that is if we are doing means. What happens to standard deviations if I'm adding or subtracting two random variables? So let's start with adding again. So I have x plus y, so my sum is x plus y. Here, you have to find the variance first. So you cannot add standard deviations, only variances. So when we do this, we're going to add the variances together. I'm going to have to square my standard deviations given, add it together. That gives me my variance, and then simply take the square root of it down here to get our standard deviation. So a hint here, two independent random variables, their variances add, not their standard deviations. Keep that in mind because it will happen. Okay, if we are subtracting two random variables, so now I have my D as x minus y. You still have to work with variances. Our equation here, you still add them. Okay, they also, remember, they have to be independent. So make sure we have that in there. If they're not independent, we can't use this formula. So even if you're subtracting, you still add your variances together and then take the square root to get your standard deviation. So adding or subtracting your two random variables, you always add the variances, no matter what. So let's look at an example. We're still going to be back to our example of Pete charging the $150 and Aaron the $175 for their tour. Or C and E are still the same thing. This time I'm going to give you the standard deviations. Okay, it says they're independent, so that's good. We can use it. So my D is going to be C minus E, which is Pete minus Aaron. It says earlier we found the mean difference is 20. We didn't actually find it, but I'm giving it to you. Or if you look at the means I gave you before, if you subtract them, you get 20. We're going to calculate and interpret the standard deviation. So remember, we can't just work with standard deviations. We have to work with variances. So we first find the variance of D. We take the standard deviation and square it of each one of them, add them together. So again, that's our variance. We want standard deviation though, so now I just need to take the square root of that. So I don't have the square root on number here. Let's see what this, put that into our calculator. And you're going to get $231.50. This is our standard deviation. So I have it written in our interpreting. And something like this, the difference, Pete minus Aaron. It's important to say we're differencing, and it's very important to tell me which order you are subtracting in because it changes your mean if you change the order. And the amount collected on a randomly selected day typically varies by what our standard deviation is from the mean difference of 20. Have to have those things in here. Last time I used the words instead of typically, I used on average. Those can be used interchangeably. Just make sure you're getting all that stuff in your sentence. So now we're just going to do a few examples of putting together all the different rules that we've looked at today. So I'm going to start here. I have a standardized exam consists of multiple choice and free response. And each section has a mean and standard deviation. The test score is computed by adding the multiple choice and free response. So kind of think about like your AP exam, for example. We want to know the mean and standard deviation of the test. So think about it. Our new random variable, I'm going to let be T for our test score, right? And our test score is by adding these two things together. So basically, my test score is adding the multiple choice plus the free response. So I'm adding two random variables together. So to find the mean when I'm adding two random variables, that simply means that I add the means together. So my mean would be 68. For a standard deviation, remember I can't just add standard deviations, I have to add variances. So that means my variances would be 6 squared plus 7 squared. So my variance, this is our variance, is 85. Square root it to get our standard deviation. Didn't ask you to interpret, just ask you to find, so make sure you can find them. Okay, and then here, example 7. At a school, each room is going to contain tables and desks. On average, we're going to have 25 desks with a standard deviation of 7. Each room is going to contain 5 tables with a standard deviation of 2 on average. Each desk weighs 16 pounds and each table weighs 30 pounds. We're going to take a room at random, so think about taking a room at the high school. We're going to take everything out of it and put it in a 10,000 pound truck. So we first just want to write a formula for W, the total weight of the truck and its contents after the truck has been loaded with the content of the room. So if we write our W, how much is it going to be? Well, we know we have a 10,000 pound truck. So we have to have our 10,000 right here. Okay, then we're going to have some desk and some tables in it. So we know that each desk weighs 16 pounds. Don't know how many there are, but I have 16 times however many desks we have. Tables weigh 30, so now I'm going to have 30 plus however many tables. So I'm using D for desk and T for tables. This is our formula. That's what you would be asked to write. Now from that, we are going to get some information. So this is just telling me the mean of desks and tables and the standard deviation. That was all from the problem. This is our formula that we wrote, 16 times our number of desks plus 30 times our tables plus 10,000. Remember, we're adding, it doesn't matter what order anything goes in. So we want to find the mean. So to find the mean, remember it changes with addition. So the 10,000 is important, and it changes with our multiplication. So we just need to plug in our mean for our desk and our mean for our tables. So we would have the expected value 16 times 25 plus 30 times 5 plus 10,000. So we work that out, and I would get 10,550 pounds. Okay, then we want to find our standard deviation. So standard deviation only changes with the multiplication part right here. So with the standard deviation, we don't care about this plus 10,000 because adding something doesn't change it. Also, when we are adding these together, we have to find variances, right? We can't just add our standard deviations. Well, we can't also just multiply by B because back when we were talking about multiplying, I said you had to multiply by the constant squared. So when we're doing our variances, you have to take the constant 16, square it, times our standard deviation 7 squared, plus 30 squared times 2 squared would give me 16,144. So this is our variance. Then square root it to get our standard deviation of 127.06 pounds. Okay, you might be asked to interpret and you might not. We are stopping there in our notes today. We'll review a little bit and finish them up next time. Let me know if you have any questions.